In this video, we are going to introduce the idea of the fundamental theorem of calculus. We're going to get to the formula version of it on the next problem. So this problem is just kind of introducing how we can find the net area. We're going to create a formula for finding the area of this trapezoid. We'll show the picture of why it creates trapezoid. And we're going to go from 2 to x, and then we're going to find the area using geometry and finding the area using the formula, and just kind of show that they are equivalent to each other. So we're going to find the net area. So here's what we're going to do. I'm not going to worry about the fundamental theorem yet. We're going to graph this and try to create some sort of a visual associated to it. So if I go about graphing this, we're going to go from 2 to x, so 2 to some value. And if we plug 2 into this equation, we're going to get a 2 times 2 plus 3 is going to be a 7. So this coordinate is 7. And if we plug x in to this equation, we're going to get 2x plus 3 is going to be at some y value of 2x plus 3. And that's all dependent upon whatever the x value is. So we'd have some point. And we would have a line from here to here. And we would be trying to find the area of that trapezoid. Right, so to find the area of a trapezoid, we would be doing 1/2 height times base 1 plus base 2. And so the height is the gap between them, between the parallels. And so if we're trying to find out what that height is, we're doing the difference between 2 to x. And that ends up being taking the higher number and subtracting the lower number. So our height is x minus 2. And then the bases are your parallels. So we want that length and that length. And so that length is the height of 7 plus the height of this, which is 2x plus 3. Excuse me. All right, and then we have our formula. So we're going to go ahead and combine some things. We'll distribute the 1/2, probably not to that one because we're going to get a fraction out of that. So we have a 1/2 x minus 2. And then this is going to be a 2x plus 10. Both of those are even, so that's a perfect one to go ahead and distribute the 1/2 into first. So you're going to be left with an x minus 2 and an x plus 5. And then if we distribute that together, we're going to get our area formula to be x squared plus 5x minus 2x, so plus 3x minus 10. So that is our area formula. And then we could use that area formula for anything that's going to start with a 2 and go up to some sort of an x value, right? So we could then say, all right, we want to know the formula from 2 to 5. We want to know the area of that trapezoid. So to specifically find that area, we're going to do our x value would be this. That's our x. We are going from 2 to x. The 2 is already incorporated into the formula. So we would go ahead and plug the 5 in. And so we'd have a 5 squared plus 3 times 5 minus 10. So we're looking at an area of 25 plus 15 minus 10. So 40 minus 10, our area would be 30. So we could do this kind of the old-fashioned way as well, with having our picture and having a height of 7. And then our other height would be if we plugged in. So we're just going to check this real quick. If we plugged in the 5, we'd have a 10 plus 3 is a 13. And so from 2 to 5, we would actually have this trapezoid that we're trying to find the area of. And so if we did the actual formula, which is what we incorporated here, we would have the height, which is the gap between them. So that's a 3. And then the sum of the bases, which are the parallels. So that's a 7 plus 13. And so we would get 1/2 3 times 20. So half of 20 is 10 times 3 is 30. So instead, we created a formula out of this that allowed us to do any value. As long as we start at 2, we go to whatever x value we want to go into, that will go ahead and account for a lot of potential different situations, so I don't have to redo this over and over and over. So that is heading towards a fundamental theorem of calculus. Fundamental theorem of calculus eventually is going to be to find our area. We're going to do the integral, the antiderivative, and we're going to have it bounded, and there's going to be a method to trying to plugging in these values and going ahead and figuring this out. And we'll do that on our next example to actually show the calc behind it rather than the geometry behind it.